Assalamualaikum, welcome back to my channel Physics from 5 SSM. Today we continue 6.2 nuclear energy. As we know, the sun provides light and heat energy to Earth since a million of years ago. So what caused sun to glow? You can see like orange color. Okay. Hydrogen nuclear fusion occurs in the core of sun under very high pressure. In this nuclear reaction, two hydrogen nuclei fuse to form a helium nucleus and release nuclear energy. Means two hydrogen nuclei combine to form a nucleus of helium. So this energy is radiated to the surface of sun in the form of light and heat energy, as shown in photograph here. So you can see the surface of the sun is like this. Okay? Nuclear energy is known as atomic energy released during nuclear reaction, such as radioactive decay, nuclear fission, and nuclear fusion. In 6.1, we have discussed about radioactive decay. So in that process also, there are nuclear energy released out. Okay, so this one is also known as atomic energy. Okay, nuclear energy also known as atomic energy. So depends on what process we discuss. So in this topic 6.2, we will discuss more on nuclear fission and nuclear fusion. The history of nuclear energy in Malaysia started with establishment of the Tun Ismail Atomic Research Centre, Puspati, under Ministry of Science, Technology and Environment in year 1972. Now the centre is known as Malaysian Nuclear Agency, ANM. Okay, this one is just a research centre to study about radioactive energy. Okay, let's look at the first one. What is this? The meaning of nuclear fission. So in this topic, we will discuss in detail what is this nuclear fission and nuclear fusion. So there are two nuclear reactions that produce nuclear energy. There is a loss of mass, or we call it mass defect, occurs during the nuclear reaction. Figure 6.8 shows nuclear fission, while figure 6.9 shows nuclear fusion. Okay, so look at the diagram below. Nuclear fission is nuclear reaction when a heavy nucleus splits, means divide to half, split into two or more lighter nuclei while releasing large amount of energy. For example, uranium-235 bombarded by a neutron, it becomes unstable. Then what happens? Uranium-236 split to two, or split to lighter nuclei, barium-141 and krypton-92. At the same time, release out energy and 3 neutrons. You can look at the equation given. Okay, uranium-235 bombarded with a neutron become uranium-236, which is unstable, then split to two lighter nuclei, barium-141 and krypton-92. At the same time, release out 3 neutrons and nuclear energy. So this is one example of nuclear fission. For nuclear fusion, in which small or lighter nuclei fuse or combine to form a heavier nucleus while releasing large amount of energy. This nuclear reaction happens under extremely high temperature of pressure, maybe millions of Celsius. It's very high temperature. Example, nuclear fusion between deuterium and tritium occurs to form heavier nuclei of helium. Energy and one neutron is also released. Look at here. This is deuterium and tritium. So actually deuterium and tritium are isotope of hydrogen. So we have hydrogen 1, hydrogen 2, hydrogen 3. So this is hydrogen. This is deuterium. This is tritium. So there are isotopes, isotope of hydrogen. Okay, you can see the proton number are the same, 1. Nuclear number different. Okay, so they combine or fuse through the process of nuclear fusion to form one heavy nucleus, helium, and release out one neutron at the same time, energy or nuclear energy. And look at the equation. Deuterium H21 combined with tritium H31 to become helium nucleus, release out one neutron and nuclear energy. So this is a process that we call nuclear fusion. Okay. Now we want to look at the relationship between energy that released during these two processes and mass effect. For the mass of the nucleus, because of the mass is too small to be stated in kilogram, thus there's a special unit used which we call it atomic mass unit. So atomic mass unit is used as measurement of mass of an atom. Mass of an atom is too small and difficult to measure using units such as gram or kilogram. Therefore, a relative comparison between mass of an atom with the mass of one carbon-12 atom is used. Isotope carbon-12 is used as reference because carbon can be found in many compounds found on Earth. Okay? So now we can carry out this activity to determine the Avogadro number also. So you can print out the worksheet here and try to answer. The Avogadro number is the number of atoms found in 1 mole of carbon-12. What is this Avogadro number? 6.02 10 to the power of 23 atoms. So this is number of atoms found in 1 mole of carbon-12. The mass of one carbon-12 is 12 AMU. So 1 AMU is defined as a mass equals to 1/12 that of mass of carbon-12. Thus, mass of 1 mole equals to mass of 1 mole of 12 carbon-12 equals to in kilogram therefore mass of 1 carbon is 12 times 10 to the power -3 divided by 6 Avogadro number. Okay, we can show here 1 AMU equals to 1/12 times 12 times 10 to the power -3 divided by Avogadro number. That's 1.6 10 to the power of -27 kilogram. Okay, so 1 AMU equals to 1.66 times 10 to the power -27 kilogram. Okay, that's the definition of 1 AMU. In nuclear reaction or radioactive decay, the total mass of decay product as shown is always less than the total mass of radioactive nucleus. This loss of mass is known as mass defect. Means if you determine the mass before and after the process, you can see there's a loss of mass compared to before and after. So the loss of mass, we call it mass defect. This one example, the process of nuclear fission, uranium bombarded with neutron. So you can see the mass is given in AMU, mass of nucleus. So total mass before fission, you just plus 1 mass of neutron plus mass of uranium. So we get 236.05259 AMU. After the fission process, it produces krypton and barium. So total mass after fission equals to mass of barium plus mass of krypton plus mass of neutron. So it equals to 235.86653 AMU. So you can see not the same. So what we do, we take the initial mass minus the final mass. So we get 0.18606 AMU. So this one we call it mass defect, the amount of mass left. According to Einstein, he stated that mass and energy are interchangeable. Relationship between the two quantities is expressed in the equation of E equals mc squared. So meaning the mass defect or the mass loss change to nuclear energy or vice versa. Okay, this is stated by Einstein. So means from the mass defect, we can use it to determine nuclear energy by using the formula E equals to mc squared. E equals to total energy release, m is mass defect, and c is speed of light in vacuum. Okay, speed of light in vacuum is equals to 3 times 10 to the power 8 meter second to the power negative 1. Remember, 1 AMU equals to 1.66 times 10 to the power negative 27 kilogram. This one will be given in the formula or below the question given. So based on the knowledge of AMU and equation, E equals to mc squared, we can calculate nuclear energy produced from radioactive decay process and nuclear reaction. But sometimes the energy that we get, if we use this formula, E equals to mc squared, so the unit sometimes is joule. If you calculate mass in kilogram, c meter second to the power negative 1, so we'll get the answer in joule. But sometimes they want you to say in EV. Okay, so how to convert the unit? So also given 1 EV equals to 1.6 times 10 to the power of negative 19 joule. Okay, so what you do, you need to joule to EV, you just divide by 1.6 10 to the power of negative 19. Thus you will get the unit become EV, and then you can add prefixes something like mega or kilo, okay, depending on the value. Okay, so look at some question regarding the problem solving involving nuclear energy. Okay, example 1, we have radium-226 decay to radon-222, release 1 nucleus of helium alpha. So mass or given for radium, radon, helium, okay, and 1 AMU also given, speed of light also given. So how to get the value of nuclear energy? Of course, the formula is E equals to mc squared. So first what you need to do is find the mass defect. Okay, how to find mass defect? The difference in total mass before and after. Okay, so all the mass already given. So how to calculate the mass defect? The mass before minus mass after. So you get 0.519 AMU. So this unit must change to kilogram. Before you substitute into E equals to mc squared, you need to convert AMU to kilogram. How to convert? Just multiply. Okay, so you will get in kilogram. Then you substitute into the formula E equals to mc squared. So you will get the answer is 7.75 times 10 to the power of negative 11 joule. Okay, you get is 7.75 10 to the power negative 11 joule. Let's say you want to convert to EV. So what you do? 7.75 10 to the power of negative 11 joule divide by 1.6 10 to the power of negative 19 joule. Okay, so what you get? Okay. You will get 4.84 10 to the power 8 EV. Okay, so this one equals to, you convert to mega equals to 10 power 6. So this one you will get 484 mega electron volt. Okay, look at example 2, nuclear fission. So one deuterium combined with tritium to form helium and release one neutron and energy. So calculate nuclear energy release, same thing, E equals to mc squared. Find the mass defect, total mass before minus total mass after. You need to use the value of nucleus given here, mass of nucleus given here. Okay, so then convert mass to the kilogram, substitute into the formula, you will get the answer in joule. Again, if you want to convert to EV, you just divide by 1.6 times 10 to the power of negative 19. So you will change the unit from joule to EV. Okay. Okay, now let's look at generation of electrical energy in nuclear reactor. Malaysia does not have any nuclear reactors. We just have a research center, okay, a Trigger Puspati, located in Bangi. So this one just for research purposes, not to generate electricity. Okay, so you can search more about nuclear reactor. Okay, let's look at what we have here, the nuclear reactor. Nuclear reactor and the process of electrical energy generation at power station, nuclear power station. Okay, you can look at the structure here. Number 1, 2, the main parts. For the main parts in the nuclear reactor, you must know its function. Okay, look at the first one. Nuclear fission of uranium-235 and its chain reaction produce heat energy. So you can see there's a uranium rod as a source of radioactive nucleus. And then number 2, we have this one, water pump here into the reactor core to absorb heat energy that is produced by nuclear fission. Because nuclear fission release up large amount of energy. This one will cause water to heat to absorb the heat energy. Okay, so what happened? Water boil. Okay, the boiling of water produces high pressure steam. Okay, here. So this steam will be channeled to the turbine. Okay, so steam flow here. You can see number 4 is turbine. What happened next? The turbine rotated by high pressure steam, which in turn rotates the magnet or coil in the generator. I hope you still remember how to generate electricity by using the concept of induction. A coil rotates in the magnetic field of permanent magnet. Okay, the steam will condense into water. Electrical energy generated is sent to consumer via a power supply transmission system. So this is how electrical energy can be generated by nuclear power station. In nuclear reactor, the fission process, uranium-235, nucleus produces 2 daughter nuclei, 3 fast-moving neutrons, and large amount of energy. This neutron will bombard other uranium nuclei and release more neutrons through continuous nuclear fission. This continuous reaction known as chain reaction. So this is nuclear fission. If uncontrollable, it will become chain reaction, cannot be stopped. And look at here, uranium-235 bombarded by slow-moving neutron. We cannot use the fast-moving, only the slow-moving will be captured by uranium nucleus. And then it becomes unstable, uranium-236, split to become krypton and barium. At the same time, release 3 neutrons. Okay, if not controlled, the 3 neutrons now will bombard another uranium nucleus. Okay, you can see how many uranium involved here. Initial one, only 1, and then the second state now is 3. So uranium will split to 2 lighter nuclei, and each of these processes will release out neutron. So now for the second state of fission, there are 9 neutrons now. If not controlled, this neutron will continue, okay, the fission process and produces more neutrons. If not controlled, large amount of energy will be released out and it becomes chain reaction which cannot be stopped. And it is very dangerous. So that's why this fission process is also a basic concept applied for atomic bomb. The chain reaction takes place in the reactor core, needs to be controlled. But if we use this fission in reactor nuclear to generate electricity, there are some safety measures applied in order to control the chain reaction. The reactor needs to have structure which can prevent leakage of radioactive radiation to surroundings. How can we control energy produced during the chain reaction and ensure that nuclear reactor is safe for electricity generation? Okay. So we need to discuss what are the safety measures, okay, carried out in the reactor nuclear. So look at again this one. In order to control the rate of nuclear reaction, the safety features in nuclear reactor also carried out. In order to control the number of nuclear fission process or rate of fission, the neutrons that produce need to be absorbed or need to control the number of neutrons involved in the fission process. So what we do, we have this one, control rod. Control rod to control reaction rate by absorbing excess neutron. So this one is made of boron or cadmium. Okay. And then for the fission process to occur, the neutron must be slow moving neutron. So they must be moderated to slow down the fast moving neutron release so that nuclear fission can occur. This one is made of materials such as graphite or water. Graphite moderator. Another safety features that taken here is thick concrete wall to prevent leakage, okay, of radioactive radiation to surrounding. And then water as cooling agent, okay, because large amount of heat produced in this process, so need to cool down. So how to cool down? use water, high specific heat capacity, like heavy water. It's able to absorb a large amount of heat energy. Okay, to absorb heat energy from the chain reaction to generate steam. This can control reactor temperature. Okay, so there must be safety features like this to prevent the reactor nuclear from explode. And then the radioactive source, uranium rod, is used. Okay, so used as fuels for producing nuclear energy through nuclear fission reaction. The use of nuclear energy as an alternative source to generate electricity. In Malaysia, electricity generated using sources like coal, natural gas, and water. We have hydropower electric dam in Bakun, Sarawak, second largest dam in Asia, used to generate electrical energy. However, countries like US, Japan, France, India, and China have been using nuclear energy to generate electrical energy. Okay, so you need to find what are the advantages of using this nuclear reactor instead of using coal or natural gas and water. Okay, so there must be advantages of using reactor nuclear compared to using coal hydropower. Okay. Another one, you can also search information about the reactor nuclear, about the cost of construction, the maintenance, location of power plants, impact on ecosystem and carbon footprint, safety, health issue, technology and expertise, waste management issue. Okay. Okay, nuclear energy is now the alternative source to generate electrical energy to meet the growing energy demand and to replace reliance on fossil fuel, because this one is non-renewable energy. Okay, however, the use of this energy is still a highly debatable issue. So in your opinion, should nuclear energy be used as an alternative source to generate electrical energy in Malaysia or not? Okay, so I think in terms of cost, this is a high cost of power plant to be built, because so many safety features need to be fixed in. Okay, and also in terms of pollution, of course, the nuclear energy is cleaner compared to coal and other using fuel. Okay, because that one will produce air pollution because some of the gas released out to surrounding. Okay, so you can study more on this to get more information about nuclear reactor. Okay, look at Formative Practice 6.2. What is meant by nuclear fission and nuclear fusion? You can look at the definition. Nuclear fission is the process why a heavy nucleus split to two lighter nuclei by emitting radiation. For nuclear fission, two lighter nuclei fuse or combine to form a heavy nucleus by emitting radiation and nuclear energy. Okay. Describe chain reaction that occurs in nuclear reactor. This one is nuclear fission. So you can use a sample of uranium-235 just now. Okay. So your uranium-235 bombarded with slow-moving neutron become uranium-236, which is unstable, and then uranium-236 split to two lighter nuclei, barium and krypton, emitting 3 neutrons. Then the 3 neutrons again bombard another uranium-235 and another 3. Okay, a fission process occurs and release out another 3 neutrons for each of the fission process, causes the number of neutrons produced become bigger, and it becomes uncontrollable nuclear fission process. It will become continuous reaction that cannot be stopped. So we call it chain reaction. Explain how nuclear reactor generates electrical energy. Okay, so you can explain by starting of uranium just now. Okay, uranium bombarded with slow-moving neutron. Okay, slow-moving neutron, which is slowed down by graphite moderator. And then it becomes uranium-236, which is unstable, split to barium and krypton, and release out 3 neutrons. To control the number of neutrons for the next fission process, using boron rod to absorb excess neutrons and control the rate of fission process in the nuclear energy. Okay, and then what happens? The heat energy that released out will absorb by water. Water change to steam. The steam will turn the turbine. The turbine that rotates in the magnetic field of a monomagnet will generate electricity that can transmit through transmission line. Okay, so you can just write in your own words to explain this one. Number 4, a nuclear reaction represented by following here. The mass effect is 0.19585 AMU. Calculate energy released by reaction. Okay, so it's given already, so just use E equals to mc squared. Okay, for number 4 here. Okay, so E equals to mc squared. Mass 0.19585. Convert to Kilogram, negative 27 times speed of light squared. Okay, 2.93 negative 11 joule. This is answer in joule. Okay. Okay, that's all my video today. Thank you for watching. Bye.